Quiz Prep, Chapter 8. Okay, welcome back. This time we're at Chapter 8 Quiz Prep. Chapter 7, we had a whole scenario around these kidney dialysis patients, these chronic dialysis patients. Now we're really shifting gears. This scenario here, see that Howard Sesso and his colleagues, they studied a population of, get this, male physicians in the U.S. Total whiplash, a totally different population. And what were they studying? They were looking at the prevalence of cardiovascular risk factors. So they were measuring, among other things, their blood pressure, right? So Sesso et al. Found that among male physicians in the U.S. aged 60 years and younger, systolic blood pressure, that's the one on the top, SBP, reported in MMHG, was normally distributed. Remember what that means, it's the little bell-shaped curve, with a population standard deviation here of 9.2. Now, I know you're probably thinking, well, what about the ones over 60? You gotta read the paper. Don't see the movie. Read the paper, okay? It's great. It's awesome. There's means in there. There's all kinds of other information. But now I'm just copying out this population standard deviation for SBP that they got. Then randomly, here's a bunch of scores from the Z table. Well, I say randomly. You know why, because that's what we've been studying. Here's the instructions. Answer the questions below based on the parameter, see the parameter, listed above from the Sesso article. Note, you do not need a Z table for this quiz because I made this little thing here because I hate dealing with that, as you noticed in chapter 7. However, you do need the T table for this quiz, so we're going to do a little T table exercise so you can get used to that thing now. And so where the T table and the Z table are, I went over this a little earlier, but just to remind you, they're in the appendix of the book, the textbook. All right, starting with question 1, you work at a large health system in the United States. And then recently, several male physicians under the age of 60 have expressed concern to you about their blood pressure because you're a nurse and they come up to you and they're like, I'm worried about my blood pressure. And you're like thinking, you're pretty young, you're under 60. What are you worried about? But you get worried. You get worried because you're a nurse. So you decide to use this population standard deviation from the Sesso article to try to estimate mu in your population, your healthcare system employee male physicians under 60, right? At your workplace there. So 9 of them, you go through a list and do a random sample. And you convince 9 of them to come in, and they're under age 60, and you measure their systolic blood pressure. So here are the results you get. This is kind of, I admit, this is a Mickey Mouse question, because this is kind of a flashback back to chapter 3. I'm telling you to compute the mean, or the X bar, for the sample. So what are you going to do? You're going to add all these numbers up, all of them up, and you're going to divide by 9, okay? Because you just want to make an X bar. So that's going to be your sample mean. I guess I'm trying to hit it home by making you go through these Mickey Mouse activities that are so chapter 3. But if you do this, the answer, your X bar, is going to be 130.6. Let me repeat, that's 130.6, which sounds about right for a systolic blood pressure, okay? So you need to have that X bar in order to answer the next question, which is, now this is where it gets hard. You decide to find the 95% confidence interval for that mu using the sample of 9 male physicians, which is why you need that X bar. So fill in the blanks below about this confidence interval. Now we get to writing on the board. All right, so go meet me at the board. Okay, now we're getting down to like the hard calculations. So I just put question 2 with all its glory up on the slide here, but I want you to notice that I put some info over here. Well, that black is not very attractive. I thought I'd turn this red before I hit record. Well, I didn't. Okay, so remember we did 9. Remember you needed that 9 already for your X bar. And below it, we have this X bar that I told you about. Now you get to see it. Then remember in the introduction, we had that was Howard Sesso's, not my, population standard deviation. But because it was so nice and got together and published it, we can borrow it for our needs. Then I want to show you this thing here. And I just want to remind you, what does that actually mean? So just as a quick summary, a confidence interval, the word interval means like a space between something. Like here's an interval, right? So what is that an interval of? So this is an Indian movie. Okay, Indian movie, right? And if you're gonna see one, see Dostana. That's like my favorite one. Okay, it's not quite as long. But anyway, so you see some information and then they have this thing called interval. This is the middle part where they turn off the movie, the lights come on, you go out, you start eating, and it's like at a play. But for some reason they call it interval in the Indian movies. Because I'm Indian, I know nobody believes it, but you know, um, and मैं हिंदी नहीं जानती हूँ if you're wondering, because nobody taught it to me. But anyway, so that's what an interval is it's in a space. So we're gonna make a space here. I'll just make an interval here. Whoops. Here's an interval. And there's a bunch of stuff going on, a bunch of stuff going on. Well, what's in that interval? What that interval is your confidence interval, whereby, and I'm going to skip ahead. See, we have 95. Okay, you're going to be 95% confident, whatever that feels like, that your population mu is between these two numbers. So this is a lower number and an upper number, right? And I like to call them lower limit and upper limit. I'm sorry, I use like statistical software. I'm all really sophisticated. So I like to use these limit things. It's very limiting, but it's the truth, right? So this confidence interval, this space, so what are you 95% confident about? Well, remember we just got an X bar, and that's definitely not a mu. We have a mu from Howard. Okay, but you cannot use Howard's mu. You're looking at your own people, at your own workplace. You got to get your own people's mu. So what the deal is you want to get a mu that's halfway in the middle here, and then on either side there's half of 95%, right? And then after you're done getting the mu in the middle, you kind of forget about the mu. The whole point of the mu was so that you could add this thing here. And you're like, well, how do I pick a mu right in the middle of the confidence interval? Well, you actually do it backwards. You get this mu, and then you calculate how big this piece is, and then you reuse that piece on either side here. That way you can get the mu in the middle, and then you decide on the limits. It's like you back calculate into it, so it's going to be perfect like this. And I just want to point out here, this little piece that you make to put on the front and the back, that's called the margin of error. Like margin. Those of you who've had cancer, I'm so sorry, or are familiar with cancer, the margin is that edge around the cancer, at the edge, the margin. Um, so that's what this is like an edge, you know. Um, and yeah, that took a long time to write, so I'm going to just say E. This big E actually means this whole piece, right? So that's what that E is made out of. So if you can somehow make that E, I'll just change colors so you can see, probably not yellow. This is an E, and this is an E. So as soon as you get that E, you can just add it and subtract it from your X bar, and then you'll get this number down here and this number up here. So that's our strategy, right? And so you're like, okay, that's pretty easy. We'll just get that E. But then you might notice that the E looks pretty complicated, right? Like, look at this E. There's all kinds of stuff in this E. There's this Z, and that Z doesn't look like a normal Z, right? Oops, I don't want to cut out my formula. That didn't work. So that Z has this little C on it. Maybe you didn't notice that until just now. That C stands for critical. Okay, and I'm not being critical of you. I'm just talking about it's a critical Z. And it's abbreviated Z sub C, like Z sub. That's what I'm saying, because I remember the first time I heard this, I was in like high school algebra, and I don't know why the teacher was saying Z sub C, because I didn't learn statistics then, but I thought he was saying Z sub C. Z sub C. I didn't know what he was saying. But then later I realized sub means the little, like it's a little downstairs there, the subscript. So Z sub C. That's how you say it, but what it means is it's the critical Z. So it's actually a Z score, right? But which one? I'll help you figure that one out. So that's one ingredient of E. Then next to it, oh, you recognize this. It looks ugly, but if you think about it, you got it. It's the standard error. It's just this standard deviation, the population standard deviation that Howard got us, divided by that square root of n, which we picked our n. All those guys came in, let you measure blood pressure. So everything's cool. So we're actually in kind of good shape right now. So let's go forward and try to fill in question 2. So I'm going to go back to red here. So with respect to your sample, what is the value of n? That's 2a. Well, I just put it on the slide, so that's probably, what did I do? I mean 9. Okay. So what is the value of the x bar that the confidence interval will be centered around? You know, what's basically I'm asking you, you know, what's in this calculation, and I told you the x bar, so let's do that. 130.6. So it's not really that hard. I know when I've given this test before that the quiz that goes with this, people come up to me and they're like, is this really that simple? I'm like, yeah, it is, because if you don't get one of these things right, you don't get the confidence interval right, and I want to be able to give you some points. But anyway, so for your 2C, for your 95% confidence interval, what's the value of the population standard deviation? Well, I put that on the slide for you. I'm just giving it away. And then for your 95% confidence interval, what is the value? Okay, here's the hard part, Z sub C. Now, how do you know? Basically, you need a Z score. How do you know? Well, the trick is in the 95. Okay, so I'm going to pull this over here and interrupt your day with some hot breaking news, and that is these Z scores. Okay, so if I had said 90 in there, see the C? The critical value of Z, or Z sub C, would be this number. Since I did say 95, which off the record is actually my favorite, okay, of all of these. I mean, I hate 98, okay, I wouldn't do 98. 99, I've done 99, you know, before. I could be talked into it, but really, I don't like 90. I don't like 98. I don't like any of these. I don't like 80. So I met an 80 before. I really only like 95. So that's what's on here. So 95 happens to be 1.96. I already memorized it because it's my favorite. So that's the critical value of Z, or Z sub C, you're going to use in this case. So, and remember, that was just on the test. So you basically just have to look in the first column, look for whatever confidence interval I said, and then look up the Z sub C. So, which was 1.96, because I memorized it because it's my favorite. 1.96. I'm drawing all over everything. Okay, now what is your margin of error? Which is basically saying, what is this blob? Okay. And so let's just draw it out. I mean, you're used to standard error by now. It's not that bad. So we're going to do, so now that we have Z sub C, let's see here, Z, what am I doing? Z sub C plus or minus. This is a shorthand way of saying you have to add it and then you have to subtract it so you get the lower and the upper limit. So Z sub C plus or minus this population standard deviation over the square root of n. How are we going to do that? Let's go grab some pretty purple color. Okay, we looked at 1.96, my favorite. Oh my god, I just love 95%. Okay, plus or minus, and then good thing I put this up here. I needed it now. 9.2 over the square root of 9. Again, I have a proclivity for perfect square. So actually, I'm going to say E equals that, this big E, which stands for margin of error. And if you do all of that, you will end up with a 6. Nice and easy. So we're going to put a 6 here. Oh, that didn't change the color like I thought it would. Oh, that's okay. You can look at that purple 6. So here is the final step. Once you get that margin of error, notice how this last question here is 2 points. Why? Because there's 2 answers. You got to get the lower limit and the upper limit. Okay? So here, what we're doing is we're honoring the whole plus and minus thing. Now that we've boiled this down to 6, what do? Well, we go back to our x bar, which was 130.6. That's just over here, right? Now to get the upper limit, we're going to do the plus. So we're going to add 6. So we're going to do plus 6. And we're going to get 136.6. Notice I demonstrated the plus. It's so much harder for me to do minus. I'm just so bad at math. Okay, 130.6. Now we're going to do the lower limit, minus 6 again, right? Because we're subtracting out that lower space. And then that comes out to 124.5. So now I'm going to go write it on the list, which it's so small and I'm clumsy here. So we're going to do, here's the interval. It's from 136.6 through, oh, I went the wrong way. I always do this. Okay, 124 is the lower limit. It's easier to say it this way. 124.5 all the way up to 136.6. This is a 2, or you can say 2. Why are those numbers important? Well, I just want to sort of reality check you. We got a mean of about 130, and if you know much about blood pressure, that's a little on the high side. That kind of makes you worry that these 9, you know how they were complaining like, oh, we're worried about our blood pressure. Kind of makes you worry. But you only measured 9 of them. You didn't measure, let's say there's just a ton of people who work at your big health system, ton of male physicians under 60. You just took a sample of 9. What you're wondering is what would the mu be of your healthcare system? And you know, these 9 are not going to represent the mu. They're just going to give you an X bar. But you can now have a range of where you think the mu really is. So the mu is between, you believe, you're 95% confident. You know, you can't know for sure unless you measure everybody, but 95% confident that the mu of your healthcare system, male physicians under 60, is between 124.5 and 136.6. And so you don't really know exactly how bad the high blood pressure problem maybe is, because down here that's not so bad, but up here that's not looking good. I digress. I'm getting all philosophical. But in any case, this is how you get the answers to question 2. So let's go on. Okay, on that last slide, I didn't have 2G. I just had it up to 2F. So I just wanted to handle that. So after making this interval, what are you 95% confident about? Well, let's look at the choices. A says I'm 95% confident that the true mu falls into the range of my 95% confidence interval. We were just talking about that. So that's the answer. But I just want to show you the wrong answers. Okay, B is I'm 95% confident that the true population standard deviation falls in the range. We're not looking at it. Like, you never hear a confidence interval of the standard deviation. I mean, people can do that, but they don't. Confidence interval of the mean, that's what we always hear. And why? Because that's what we're always doing. So it's of means and not of standard deviations that this interval is talking about. C is I'm 95% confident that my sample is not biased. You can't know that. That has to do with how you screwed up your sampling. So that has to do with sampling. That's chapter 1, blah, blah, blah. And then finally, D is I'm 95% confident that SBP is normally distributed. Well, you can't figure that out from confidence intervals. You have to actually do a study and make histograms. You have to just measure people. And you know, what's kind of weird in the world is SBP does tend to be normally distributed. Like pretty much any population you go to, you get kind of a normal distribution. But then you have other things like, for instance, the length of stay in the hospital, that's always right skewed, which is kind of good because you wouldn't want to stay in the hospital that long. Okay, well anyway, we're going to go on to question 3. Okay, so one of the things we always have to remember to learn in statistics is new vocabulary. And if you have, you know, the good statistical vocabulary, not only do you communicate well with statisticians or other people doing statistics, you also sound really smart when you talk to people who do not know how to do statistics. So one of the things that will happen to you in your life if you're hanging around healthcare wonks or research wonks is you'll find once in a while there's like this emergency where somebody's running down the hall saying, I need a power calculation. and you'll say, whoa, 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 what's wrong? They're like, I'm submitting a grant. I need a power calculation. They also mean, I mean, it's interchangeable. They need a sample size calculation. They need, it's like an emergency. And is there a statistician in the house? We need to make this sample size or power calculation. Now, I prefer to say power calculation because I'm from Minnesota and we have a lot of wrestling there. And we also have truck and tractor pulls in the Metrodome. I guess they're taking that down. But we say like power, power, power at the Metrodome. Metrodome, Metrodome. So the power of the power calculations, you hold that person's life, their grant in your hands. So if you're one of those nurses walking down the hall and somebody's flailing around, I need the power calculation, I need the sample size, just calmly stop them and show them this part of the video, okay? So find the sample size necessary for a 95% confidence interval with a maximum margin of error equals 3. So this is like you're back calculating, well, how many people do I need? What n do I need if I'm gonna fast forward, do a study, get some stupid X bar, and then end up with a confidence interval, like this would be the lower limit and the upper limit, and you don't even know what your X bar is going to be, but you want to have the E over here and the E here, the margin of error, be 3 and 3. So how do you arrange all that? Like, how many n's do you need? And you're probably like, well, how would you know that? Well, I put this up here. I couldn't find a better picture of it. This is the rearranged version of the equation that we looked at before with the plus or minus in it. It's just rearranged, and it was done with algebra, which I'm not good at, so I don't want to demonstrate that part. But see how I was saying I put this n question mark? Well, that's nice. Just remember, as a general rule, if you're trying to calculate something, you want the something isolated next to an equals. And so I was so happy we have this formula, because this formula isolates the n, and that's what we're trying to figure out. Okay, so let's actually try and fill in this formula. So we're going to do, I always rewrite n equals, so this is a big parenthesis. So we have z sub c in here. And actually, you know, we have 95% confidence interval. Remember z sub c, I'll just put it up here. Z sub c for that is 1.96, my favorite. Okay, so getting back to the equation, z sub c times, we'll put a little star here. It's going to be 9.2 because that's our population standard deviation this time. Over the E, and then you're like, well, where is the E? Okay, well, in this case, when you're doing a power calculation or a sample size calculation, the E is going to be in the question, which is the margin of error, right? And that's 3. Oh, I put in this z sub c. I should just put in 1.96. You get what I'm doing. Like, you're used to me by now. This is like the, I don't know, 13th or whatever video I've made. Okay. I mean, if you're my fan, if you're just dropping in, you'll notice that I talk and I draw and it doesn't always match, and I guess that's life. Okay, so I tried to fill it. Oh, I forgot something really important, and that's that 2 up there. So I tried to fill this in according to what you would fill in to get this to work, right? And then I'm going to answer actually these questions on the left. So 3a, for your calculation, what is your z sub c? Well, we already know that's going to be 1.96 because we talked about all that. What is the value of the population standard deviation? That one's kind of a gimme. That's 9.2. Okay, and what is the value of your margin of error? Remember, in the sample size calculation, it's in the question, so that was 3. So then that question 3D is long, but it's basically saying what's the answer? How many male physicians under age 60 years old from the U.S. are required to have a 95% confidence interval with a maximum margin of error of 3? And but the reason they say maximum is you might get a smaller one, but you just have to hedge your bet. You don't know what you're going to get, right? So how we do, if you actually do this whole equation, you're going to get 36.1. Now, that's not a problem. Physicians, nurses, all kinds of healthcare providers tend to be really good participators in studies. The problem is trying to get 0.1 persons to participate. It's like their arm or something. So whenever you do a power calculation, you want to round even if it's close to 1, you want to round it up to at least the next one. So technically, to get your answer right on this, you've got to make sure it's rounded up because you don't want to recruit someone's arm or their leg or their nose, or if they have long hair, you can recruit their hair, but if they're bald, you can't recruit their hair. But anyway, so I just want to remind you that of that little caveat. And then off the record, this is completely off the record, when I do power calculations, when I'm the person who saves the life of the person screaming and running down the hall, I know that sometimes our population standard deviation we're using isn't, I don't really trust it. It's like from Australia and I'm in the US, or it's men and, or some, men that are of a different age group. I don't know. What I'll do is I'll hedge. I'll add, I won't stick with the 37. I'll add on maybe a third more or half more. And I say, let's target this. And I say it in the grant. I just tell them I made a adjustment, for attrition because people drop out and stuff. But anyway, that's off the record. For this quiz, all you do is whatever you get as the answer. If it's got point something, just make it go up to the next whole number and everything will be cool. Okay, moving on to question 4. It feels like we're not very far because 4 is low, but actually I did A, B, C, D, E, so we're doing really well. So good job. Okay, we're going to get moving on to question 4. And one of the things that really bothers me is that in the US, we really didn't study women. We would just have men only studies for a long time. That started to change in the late 80s and early 90s, after women got a bunch of treatments that had never been studied on them. So let's see if we can catch up, right? So, Howard, as much as I love you, man, you didn't study women. So question 4 is about that. So back with your scenario, you're a nurse and these male physicians are worried about their blood pressure. Well, now you know that female physicians under age 60 are also at high risk for cardiovascular disease, right? So unfortunately, the CESO article only measured men, so you do not have a population standard deviation to use. So that's where we're moving off the grid of that. We're going to have to do something else. We can't use that 9.2 anymore. Instead, you take an SBP reading from a random sample of 9 female physicians under 60 at your workplace, and you get the following results. So I don't make you Mickey Mouse through making an X bar. I give you your X bar, which is a little bit better. It's 120.2. And then I give you your own population standard deviation that was made out of these 9 ladies that did that. So you decide, so you're like, cool, I'm good with confidence intervals, I'm good with margins of error, I can take this, I can handle it. So you decide to estimate mu of this population. That's what you're doing when you're making confidence interval. You're making this range where you think mu is in there. Estimate mu of this population with a 95% confidence interval, but you have to use S. You can't use that population standard deviation. So this is sort of the $69 million question right now. I wish I could give you that much money. All right. Why are you required to use the T table? Remember, we've been using the Z table the whole time. Why are you required to use the T table on this question instead of the Z table? Well, it comes with, you know how I was talking so glowingly about, oh, just don't worry about it. Just use this like sample standard deviation. You can't use the 9.2 from the guys, but you can just use the ladies. Well, I just want to contextualize. When CESO measured his guys, he measured a lot of guys, and he did a really thorough job of getting just a lot of people together. So that estimate is probably pretty good. If you measure like only 9 people, I don't care who they are, that's not a very stable estimate. I mean, you measure 9 more, it could change a lot. So it's just a lower quality estimate. And when you have a lower quality estimate, you can't use the Z table. That's really for big things, estimates that come out of big samples. If you have a small sample, you got to take a penalty. And by taking a penalty, I mean you got to go over to the T table. So we'll learn what that penalty looks like, okay? So question 4A is, why are you required to use the T table on this question instead of the Z table? So let's go through the possible answers. A is because the CESO article is biased since it did not include women. that may or may not be true, but again, remember I said in the last question, bias really can't be assessed by looking at confidence intervals or anything like that. Bias is something that happens in sampling. So the fact that they didn't sample any women, that's a different question, like a chapter 1 question. Okay. Now, the next possible answer is because SBP is not normally distributed. Well, first of all, that's so totally wrong. Oh my gosh, like I said, every time I measure it, it's normal. It's always different mean and standard deviation, but man, it's so normal. And so even if it wasn't, that's none ya business, because right here, when we're doing confidence intervals, you need to go back to chapter 2. You need to do a histogram or whatever to figure out if it's normally distributed. You shouldn't be worrying about that in chapter 8. Either it is or it isn't, and you should just know. C is attractive. C says because the population standard deviation is unknown, because CESO didn't include any women, and we have a sample size of less than 500. And I'm being very liberal here. Personally, if we have kind of a small, if we have more than maybe 100, I'm kind of cool with it. But less than 100, you really got to do something, because I just don't trust that whatever our sample is going to give us a really good estimate. Now, if you do things like I do, where you do huge surveys, if the nurse in this like scenario was like all caffeined up and went out and surveyed like hundreds of female physicians under age 60, we wouldn't need to resort to the T table. If she had like 350, I say 500 a slide, but still, she or he had 500, or it's 350 or 400 or something, I wouldn't go into the T table. And you'll notice it doesn't even go up there. I'm going to jump ahead here. Here, the T table, it kind of ends up here above 120. There's like an infinity, and this is the degrees of freedom over here. Remember, degrees of freedom are n minus 1. So, like if I had, I don't know, 100 people, then my degrees of freedom would be 99, which is up in this bracket. You're almost maxing it out. So, so that's why. This is really why it's C. And then D is because the Z table does not have a probability for 95% confidence interval, what the T table does. Well, duh, you should know that's wrong, because I love the Z, which is 1.96. I love it, and I've been talking about this, so D is not right. Okay, so now we're going to answer the rest of question 4 together using the drawing on the board modality. Okay, look at all these questions, but it's the same MO as the last one. Remember, I made you just put the ingredients in as the answers. So why don't we just start working through this? First, I just wanted to point out I made a little change over here to what's going on here. So what's different? This is kind of like those games you play where you have 2 pictures and then what's different than the other, but I didn't show you the first picture. Here's what's different. I'll just cut to the chase. This T sub C, right? Instead of Z sub C, we have the critical T instead of critical Z. And remember, critical Z, we just looked up on my little, on the actual quiz prep. Critical T, we're going to actually have to look up in the T table. I'll show you how to do that. The other big difference here we have is this S at the top. That's the lowercase s, right? That's the sample standard deviation that you got. And I even put it up there, that 120.2. That's the one we have to use. I'm sorry, the 8.6. This is it. And then the 120.2 is the X bar that we got. I just transcribed that from the question we just went over. Okay, so those are the differences. Let's just jump into 4B. With respect to your confidence interval equation, what is the value of n? Well, we've got it on the slide, 9. I didn't change that. With respect to your confidence interval equation, what is the value of the degrees of freedom? Aha. So remember, the degrees of freedom are needed for the T table. And the degrees of freedom, they're like this. I like to make the fancy F. Degrees of freedom equals, it's so hard. I should have put it on the slide. This is a very difficult equation. Let's see if I can remember it. N minus 1. Awesome, I remembered it. Okay, it's n minus 1. So what would you do? 9 minus 1 equals 8. And I just want to, before we go forward, point out where this comes into play. See, this t-table, see this df? They didn't use a fancy f, but this is where you would go. So because we just calculated an 8, we'd be looking under the 8 row. So that's why you want to get the degrees of freedom correct. Is if you're going to use a t-table, you need a degrees of freedom. You got to be told what your n is. You minus 1, and then the first thing you do is just look for the right row. Any of the numbers you need, any of the t sub c's you need is going to be in that row. And so that's what we're going to do once we figure out exactly. The next step is we got to figure out what column we want, right? So, okay, so that's our degrees of freedom. We'll just put that in here, 8. And what is the value of x bar? We have that, I got that from the question, which I gave you. So you shouldn't get that wrong. With respect to your confidence interval equation, what's the value of s? Well, that's on the slide too, so you shouldn't get that wrong. And what's the value of t sub c? Okay, here's the hard part, right? And remember, this is the key again, just like with the z one, it's 95%. So, like I already said, we figured out we need the 8 row. Well, what do we need up here, right? So, this alpha hash mark and this alpha 2 hash mark and then the c. This is a multi-use table, and what we're going to do is we're just going to look at the c. Obviously, we're doing t sub c. We're just going to look at the c line. Okay, so what we're going to do is go across and look up, what do we want? 95. See this? I go this, do. That would be 95% if I moved it over, but it's like a proportion. I don't know why they had to make it hard. So now we know it's this third from the right. This is the column. So you look in the C one, you look over. Now if on the quiz I'd put like 90%, you'd be looking in that column. Or if I put 98%, which I would never do because I hate 98%. I might put 99, but I really do not like 98%, so you can just rule that out. And I don't like 80. Oh, I had a bad experience. But anyway, so 95 is my favorite, and you'll probably see it around, but you might see 90 because sometimes I do that. And then what you would do is figure out that column, and then you go over to the intersection. So in this case, we got 8 degrees of freedom, and we're looking at 2.306. So the T sub C is 2.306. Okay, I can't forget that. Gotta go write it down. So that's T sub C. I gotta be careful when I write this. 2.306. And sometimes people get really picky. I'm not. They go, oh, that's 95% confidence interval at 8 degrees freedom. Like they write a bunch of notes at the bottom. But it's just like kind of obvious to me. So that's all you need to write, right? So the answer to 4F then is this. It's 2.306. Just put that. I get it. So then 4G, what is the margin of error? Well, this was the whole point. We needed this. We got the S from the question, but we needed this. Let me clean this up here so I can do a whole, oops, that didn't work. I want to do a whole equation for you for this ME. So remember the ME. Oh, I cut off some of my end, but you get what I'm talking about. So maybe I should change it colors. Let's use some blue. So we're going to make this ME over here. I'm not used to this. ME. Our special ME that uses a t-table. So I say ME, margin of error, or it's just big E. So I can get some real estate over here too. Okay, so let's just deal with this E. So we're going to do E equals T sub C times, I'm going to just overdo it, times the S over the square root of n. Remember again, you got to do the square root of n before you divide it into the S. So how do we get that? Well, I wrote everything down here. So it's 2.306. If I write big, I don't screw up as much. And we'll do 8.6. Remember that's up there. Over the square root of perfect square 9. Okay, if you actually do that, you're going to get a 6.6. And that's what we'll put over here, the 6.6. So the challenge is, are you used to confidence intervals yet? Because if you are, you know why we have that. Like why is this margin of error coming into our lives? Because the whole point is to get the lower and the upper limits, right? So so how are we going to do that? We're going to do, see this, that's where this plus or minus comes in over here. So we're going to start the first one. So x bar plus the e is going to be the upper limit, and the x bar minus the e is going to be the lower limit, and that's why we went through all this business to get this e. So what's our x bar? 120.2. So this time I'm going to do them in order, otherwise I get totally screwed up. So I'm going to do the lower limit first. We're going to go minus, and then this is 6.6. Remember our e we just made. And I'm even bad at this kind of math. So I'm going to just say 113.6. I already prepared this. So that's the lower limit. Let's put that over here. 113.6. And then we'll say 2. Like we're going to make it bigger. And then I'm just going to erase that because that's just way too big and totally in my way. And then we're going to do the upper one. Well, you're probably so sick of this now because it's actually not that hard and you're a pro. Now we're going to do the plusy deal, 0.6. And if you don't have trouble with addition like I do, you would get, I didn't even write this right, 126. It's kind of kitty wumpus there. 126.8. So that's at the upper end, 126.8. Messy. But just before we end, I just want to reality check you. So what happened was you were hanging out at work, read the SSO article. Some male physicians are like, oh my gosh, I'm like under 60 and I'm worried I got blood pressure issues. And so you measured a sample of them and tried to estimate that population blood pressure, and what you came up with was it was somewhere between 124.5 and 130.6. And so if there are treatment guidelines in there that start at, for instance, 125, you probably should start treating them because the lower part is well, you wouldn't know whether to start treating them because it's like the lower part is before 125, but most of it would be in there, and so you're probably like, yeah, I probably should treat everybody, not just the sample, everybody. But later, you you asked the question about women, and you had to do things differently because you couldn't use the SESO standard deviation. So you had to make a sample standard deviation, use the t-table, but then this time you came up with a kind of, this is your confidence interval, and the whole thing is lower. The bottom one is near 113 and the top one is near 126. Well, if there's treatment recommendations at 125, I don't remember what they are. I haven't looked up the JNC, but then you'd say, well, most of these people are probably not 125 and older, over. So you wouldn't want to just give everybody blood pressure meds. So this is my little story from public health land as to why we make these confidence intervals. If like high blood pressure, the cut point to high blood pressure is like 130, and if you're looking at your bottom one for some population, like maybe these kidney dialysis people would have high blood pressure, that's very typical. If you look at the bottom of your confidence interval and it's above the treatment guideline of 130, it just gets worse the more you go up that that's a lower limit. So that when you see that, you're like, treat. Let's find the population. There's an issue with the population because the whole confidence interval's up there. Like you're 95% confident that the mu is in a really difficult spot. All right, so that was my little public health soapbox there. I know all you're trying to do is get through this statistics class. Well, you've done a good job. So we've gone through all of our chapter quiz preps. This is quiz prep chapter 8. Good luck on the quiz, but also just good luck in life because this is our last quiz. And thank you for listening. Those of you who have listened faithfully to all of these quiz preps, I really appreciate it. And those of you who just showed up and said, hey, I'm just interested in confidence intervals, thank you. Thank you for listening. All right, good luck.